So in this video, I'll be showing you how to balance a chemical equation, and we're going to be balancing about 4 chemical equations in this video, starting with this simple one. Now, an equation is said to be balanced when each of the elements that makes up the equation have equal number of moles on the reactants and on the product. Now, that simply means that for nitrogen on the reactants, the number of nitrogen on the reactant must be equal to the number of nitrogen on the product. The number of hydrogen on the reactant must be equal to the number of hydrogen on the product, and so on. Now, when balancing simple chemical equations like this, the first thing you do is to make a table. Okay, we'll make a table. So this represents the reacting elements, reactant, and this represents the products. Now, you pick out all the elements that makes up the reactants. So I can start with nitrogen. I have nitrogen. How many moles of nitrogen do we have there? Simply 1 mole of nitrogen. I have hydrogen. How many moles do we have on the reactants? I have 3 moles of hydrogen. I have oxygen, and I have 2 moles of oxygen. Now, you also do the same thing for the product, starting with nitrogen. Nitrogen on the product is actually 1 mole, so I just have 1 nitrogen there. For hydrogen on the product, unfortunately, we have 2 moles of hydrogen on the product. And for the oxygen, now, whenever you're trying to balance a chemical equation, you try to represent the elements the way they are on the table, right? So you see that nitrogen appeared alone on the reactant side and on the product side, so that's why we're putting them as 1, 1. But oxygen appeared 2 places. I have oxygen attached to H2O. I have oxygen attached to nitrogen, and each of them are 1 moles. So instead of writing total of 2, you simply pick them as what? 1, 1. Okay, so I have 1 mole of oxygen attached to the H2O plus 1 mole of oxygen attached to the NO, that's nitrogen oxide. So total of 2 oxygen atoms. So we have 2 oxygen on the product, 2 oxygen on the reactant, 1 nitrogen on the product, 1 nitrogen on the reactant, but 3 hydrogen on the reactant and 2 hydrogen on the product, which means our hydrogen atom is not balanced. Now, it is important for you to know that in balancing a chemical equation, it is wrong for you to want to append a subscript where it is not given. For instance, just to say, let me just put N2 here, something like this. This is actually wrong. Or say O3. This is actually wrong. You don't put a subscript. Or any number you're attaching to a chemical equation must always be appended at the back of each of the equation. For instance, 2 times the whole of this. Okay, so also keep that in mind. Let me take this off. All right. Now, we need to balance our hydrogen atom. Since I have 3 moles of hydrogen on the reactant and 2 moles on the product, then we need to make them to be the same. In order to do that, all I need to do is simply what? Multiply. So I can easily multiply the hydrogen atom by 2. That's for the one on the reactant. So this is going to now give me what? 6 hydrogen atoms. Then for the product, I will simply multiply here by what? 3. This will give me also 6. So you see now that hydrogen is balanced. But now let's effect these multiplications on the equation. Now on the reactant, I multiplied 3 by 2. So which means hydrogen have been multiplied by 2. So like I said, you can't come under here at the subscript and write 6. That is against the law of balancing an equation. Rather, this number that I multiplied now to give hydrogen 6 have to be multiplied at the back of the compound where hydrogen is found. So I multiply the equation by 2. That means this is going to be, I will simply append 2 at this back. So it means 2 times every of the elements there. So that means that 2 now is now affecting nitrogen. The same thing happens on the product. On the product, I multiplied hydrogen atom by 3. And hydrogen atom is found there, so which means I'm going to be appending 3 at the back of water because I multiplied that equation by 3. So with this now, I have 6 moles of hydrogen on the product, 6 moles of hydrogen on the reactant. 2 times 3, that gives us 6. But you observe now that on the product, on the reactant, this 2 is affecting what? The nitrogen. So the 2 will obviously be multiplying the number of moles of nitrogen. So since I have nitrogen as 1 on the reactant, so 1 multiplied now by these 2 simply gives us 2 moles of nitrogen. So now I have 2 moles of nitrogen on the reactant. So which means I also have to balance this on the product. But before going to the product, let's now observe our oxygen, because this 3 here, which I multiplied to the water, also affected this oxygen. Remember the position of the oxygen? We said oxygen is simply 1 plus 1 initially. Now, this 3 multiplies this 1 mole of oxygen here, turns this particular one to 3. So I can now take this off and simply attach 3 there. So this becomes 3 plus 1 because of this 3. So this 3 simply multiplies this 1 mole of oxygen. It becomes 3 moles. So it means that now on the product, I have a total of 4 moles of oxygen. But on the reactant, I have a total of only 2 moles of oxygen. Now, before coming to this, let's now balance up the nitrogen atoms, right? So nitrogen on the product, on the reactant is 2 now. On the product, I have to balance up nitrogen as well. So which means I have to multiply nitrogen by 2 to make it balance, since I have 1 mole on the product. So simply multiply this by 2. This is going to now be equal to 2. So which means I will multiply this equation by 2, NO. Remember again, it is wrong to come here and simply put N2O. That is against the law of chemical balancing chemical equation. So you can't do that. You simply append the 2 at the back. So which means this 2 is multiplying everything in that equation. So now you observe that I have 2 moles of nitrogen. Nitrogen is balanced on both sides, but these 2 now affects this oxygen. Now I have 3 moles plus 1 mole of oxygen. Now 2 times this 1 mole of oxygen becomes 2. So I can now simply take off this 1 and replace it with what? The 2 moles of oxygen. So this becomes 3 plus 2 moles of oxygen. Now let's take a look at what we've achieved so far. On the reactant, I have 2 moles of nitrogen. On the product, I have 2 moles of nitrogen. On the reactant again, I have 6 moles of hydrogen. On the product, I have 6 moles of hydrogen. Now on the reactant, I have 2 moles of oxygen. But on the product, I have 3 plus 2, total of 5 moles of oxygen. So which means oxygen is yet to be balanced on the product. Now what do we do to balance oxygen? You observe that if this is 2 and this is 3 plus 2 here simply gives us 5 moles of oxygen. Let's just indicate that this is 5. Now since oxygen is standing on its own here, you can actually do something to bring it to what? 5. So see, this is 5 moles, and I have the subscript here to be 2. And remember that any number you append at the back will be multiplying by that 2. Okay, so you simply recall that if I have 5 over 2, okay, 5 divided by 2, multiplying 2, see that 2 cancels 2, I will simply have what? 5. So which means if I multiply this equation by 5 all over 2, I'm going to be having 2 to cancel 2, giving me just 5 moles of oxygen. So which means I'm simply going to append 5 all over 2 here. And if you do this, it means that this chemical equation is balanced, because 5 over 2 multiplied by the 2 moles of oxygen already existing there simply gives us 5. Now let's count everything we have. Nitrogen is 1 on the reactant. Nitrogen is 2 on the reactant. Nitrogen is 2 on the product. Hydrogen 6 on the reactant, hydrogen 6 on the product, oxygen total of 5 on the reactant, oxygen total of 5 on the product. So it means that our chemical equation is balanced. Now let's pick the next example. Okay, so let's consider this particular equation, and let's say we are asked to balance this chemical equation. Once again, you make your table of product and reactant. So we make our table. So this is our reacting element, reactant, and we have this to be the product. So you pick out all the elements that makes up the reactant, starting from carbon. I have carbon. How many moles of carbon on the reactant? Simply 1. I have oxygen. So remember what I taught you about this. Now do not count the total number of oxygen and just put it. I have 2 moles of oxygen attached to carbon. I have 1 mole of oxygen attached to hydrogen gas. So you can simply write it as 2 plus 1. So it makes it easier for us to balance like this. Next is hydrogen. So for hydrogen, I have simply 2 moles of hydrogen. Now on the product, same thing, carbon. I have 6 moles of carbon. Okay. For oxygen, on the product, I have total of 6 plus 2. So I have 6 plus 2 moles of oxygen. Okay, and for hydrogen, I have 12 moles of hydrogen. So let's see. Carbon is not balanced. Carbon is 1 on the reactant and 6 on the product. Hydrogen atom itself is 2 on the reactant and a total of 12 on the product. So let's start by balancing hydrogen atom. Since hydrogen atom is 2 on the reactant and 12 on the product, it means that I can easily multiply here by 6. That simply gives me what? 12. So if I multiply the reactant by 6 for the hydrogen atom, I'm going to have 12. So which means I will simply append 6 at the back of hydrogen. So 6 times 2 gives us 12 moles of hydrogen. But you observe that this 6 is now multiplying this oxygen atom here. And remember, for the oxygen atom, I have 2 plus 1. This one now is now going to be 6, because 6 times this 1 mole becomes 6. So in place of this one, I will simply replace it with 6. So take this one off. It becomes now 6 moles. That becomes 2 plus 6 moles of oxygen. And 2 plus 6 is 8. And you observe that on the product, I have 6 plus 2, also 8. So oxygen is balanced. But carbon is 1 on the reactant and 6 on the product. So which means I can simply multiply carbon by what? 6 on the reactant. That will simply give me 6. Carbon is balanced. But let's confirm that. It means I have to now append 6 at the back of carbon here. If I do that, this 6 is now going to be multiplying these 2 here. So in place of these 2 moles of oxygen, it becomes 6 times 2, that is 12. So which means I'm going to be having 12 plus 6. Okay, that becomes 12 plus 6. So total oxygen on the reactant is now 18, but on the product, total oxygen is 8. So which means something needs to be done. Okay, something needs to be done. Now you observe that I have this is now 12 plus 6. So let's just say 6 for 6. We need 12 now. Since I have 6 already here, we need 12 moles of oxygen to make it what? To make it balanced, right? To make it 18. So I have oxygen as standing here. If I multiply this oxygen gas by 6, 6 times 2 gives us 12, and oxygen becomes balanced. So which means all I need to do is to multiply here by 6. If I multiply this by 6, 6 times this 2 becomes 12. So in place of this 2 here, we replace that 2 with what? 12. So I have now 12 moles of oxygen. Let's take this off and replace it with 12. Okay, so it becomes plus 12. Plus 12. So now the equation is completely balanced. 6 plus 12 simply gives us 18 moles of oxygen. 6 plus 12 on this side also gives us 18 moles of oxygen. Hydrogen is 12. Hydrogen is 12. Carbon is 6. Carbon is 6. And the equation is balanced. So this becomes the balanced chemical equation for that given question. Let's pick the third question. Now let's attempt to balance this chemical equation. Once more, let's pick out all our reacting elements. So I have silicon on the reactant, just 1 mole. I have chlorine on the reactant, and total of 4 moles of chlorine. So I have hydrogen, a total of 2 moles, and I have oxygen, total of 1 mole on the reactant. So let's repeat the same for the product. Silicon. On the product, I have 1 mole of silicon. Chlorine. On the product, I have just 1 mole of chlorine. Hydrogen. On the product, I have 5 moles of hydrogen, but they are now being spread as 4 and 1, so 4 plus 1. Okay, and then for oxygen on the product I have 4 moles of oxygen. So let's see what is missing. Silicon is balanced. Chlorine is 4 on the reactant and 1 on the product, so that's not balanced. Hydrogen is 2 on the reactant and 5 on the product, also not balanced. Oxygen is 1 on the reactant and 4 on the product, also not balanced. So let's start by balancing. Let's start from oxygen, right? So if oxygen is 4 on the product and 1 on the reactant, so I can simply multiply here by 4. So this is going to be equal to 4, which means oxygen is now balanced on the product and on the reactant. But then it means I have to append 4 at the back of hydrogen here. So 4 times this oxygen gives us 4 moles of oxygen. But this 4 now is affecting the hydrogen atom on this reactant. So this becomes, instead of 2 now, it becomes 2 times 4, which equals 8. So I have now total of 8 moles of hydrogen. But on the product, I have 4 moles of hydrogen. 4 on this other part of the equation, that's H4XiO4. Then 1 on hydrogen chloride. So I can simply append 4 here. If I append 4 here, this 4 multiplies by this 1 mole of hydrogen, it becomes 4. So I can now easily take off this one and append 4. Okay, let's just turn it to 4. So this one now becomes 4 moles. So it means now that hydrogen is equal to 8. So hydrogen is balanced on both sides of the equation, but this 4 now affects this chlorine. Okay, so instead of being 1 here, remember chlorine here is 1, it becomes chlorine 1 times 4, which is equal to 4 moles of chlorine. And observe that on the reactant we also have 4 moles of chlorine. Silicon is 1, so it means that the equation is balanced. Okay, so it means that the equation is balanced. So one more question and then we'll wrap it up for this video. So this is our final question for this video. In the next video we are going to be continuing with more tedious questions. Okay, so once again, let's pick out all elements. I have aluminum, just 1 mole of aluminum on the reactant. I have hydrogen, also 1 mole. I have chlorine, also 1 mole of chlorine. And on the product, I have aluminum, also 1 mole. I have chlorine, now 3 moles. I have hydrogen, 2 moles. Okay, sorry about that. Hydrogen comes first. Hydrogen is 2 moles on the product and chlorine is 3 moles on the product. So let's start by balancing chlorine. Chlorine is 3 moles on the product, so all we need to do is simply multiply the reactant by 3. So chlorine becomes 3 moles on the reactant. So if I'm multiplying this by 3, it means where chlorine is found on the reactant, I have to append 3 just at the back of that equation. So you have this. So this means now that this 3 is now affecting the hydrogen atom there. So which means hydrogen is now being affected by this multiple 3. So I have 1 times 3. So I have 3 moles of hydrogen there. And but hydrogen on the product is actually 2. Okay, hydrogen on the product is actually 2. So what do we do now to bring this hydrogen to be equal to 3? Simply multiply by 3 all over 2. It's as simple as that, such that the 2 cancels 2. I am left with 3 more. So here I'm going to be multiplying this by 3 all over 2, and it is easier because the hydrogen gas atom here is standing on its own, so it's very easy to do. 2 cancels 2. I'm left with only 3 moles of hydrogen. So simply multiply here by 3 all over 2, and that's it. Aluminum is balanced, hydrogen is balanced, chlorine is balanced. This becomes the balanced chemical equation for that given question. Alright guys, so that's it for this video. I'm sure you enjoyed the video, so do well to like, comment nicely, share to your friends, and if you're new to the channel, do well to tap the subscribe button right now and turn on your notification bell so you don't miss out on the next video when it drops. In the next video, we're going to be solving more tedious problems involving balancing chemical equations. I'm sure you don't want to miss that video, so do well once again to tap the subscribe button and turn on your notification bell so you don't miss out on that video when it drops. I will see you in the next video. Thanks.